Hey everyone. So, when you think of demolition, you probably picture a giant explosion, right? Hollywood style. But today, we're diving into the real world of modern demolition. And trust me, it's an incredible blend of precision engineering, wild chemistry, and some seriously heavy machinery, all coming together to take down the biggest things we build.
I mean, that's the big question, isn't it? You've got a skyscraper, a massive bridge, or an old factory that's at the end of its life. You can't just swing a wrecking ball at it anymore. It takes a ton of planning and some really sophisticated techniques. So, how do they actually do it? Well, let's get into the main methods.
All right, first up, the one we all think of blasting. But this is so far from just chaotic explosions. It's really the technological spearhead of modern deconstruction. For things like huge industrial chimneys, cooling towers, or sprawling concrete bridges, sometimes blasting is the only way that's fast and economical enough to get the job done.
Okay, so the core idea here is actually pretty surprising. The goal of a demolition blast isn't to obliterate the building with a massive shockwave. It's way smarter than that. Instead, you use a very precise amount of chemical energy to strategically remove key supports, and that releases the building's own incredible potential energy, basically letting gravity do all the heavy lifting. The building literally demolishes itself.
Now, how it collapses depends entirely on the strategy. If you've got a building in a crowded city, the experts will use what's called a folding blast. They set charges on multiple floors to make the whole structure accordion down, collapsing neatly into its own footprint. But if you have tons of open space, they might go for a toppling blast. They create a notch at the base, and the structure falls over in a specific direction, kind of like a lumberjack felling a giant tree.
And here's something crucial. A building is never blasted in its original state. For weeks, sometimes even months beforehand, crews go through this process called pre-weakening. They'll take out non-essential walls and strategically cut or drill into the main load-bearing columns. It's this super delicate balance of weakening the structure just enough for the explosives to work, but not so much that it comes down on its own. And it is absolutely not one big bang. First, they drill hundreds of holes. Then, they place the charges. For steel, they often use special-shaped charges that create this high-energy jet of plasma that slices right through thick beams. But the real magic? It's the timing. Electronic detonators trigger the charges with millisecond delays. This creates a kind of chain reaction that guides the collapse and staggers the impacts, which massively reduces ground vibrations.
Of course, explosives aren't always the right answer, so next up, we've got the powerful and methodical world of mechanical demolition. A lot of the time, this works hand in hand with blasting, or it's the main go-to when you're in a more sensitive area. So meet the absolute workhorse of the modern demolition site, the long front excavator. These things are true engineering marvels. They're specifically designed to tear down tall buildings, piece by piece, all while the operator is sitting safely down on the ground. And their reach is just incredible. While a lot of them can reach up to 50 meters, some of the newer prototypes are pushing 70 meters. I mean, that's high enough to take down a 20-story building, dismantling it from the top down with almost surgical precision, all controlled from the ground. These excavators have a whole arsenal of attachments. You've got hydraulic hammers for smashing, massive shears that just snip through steel, and pulverizers that crush concrete right on the spot. The newest pulverizers even have what they call speed booster tech that separates the steel rebar from the concrete in seconds. Yeah, it's slower than blasting, but it lets you sort materials as you go. Even these giants have their limits, though, especially against things like old reinforced bunkers. But what if you can't use explosives, and a giant excavator is just too loud or creates way too many vibrations? Well, for those situations, you've got some really clever, specialized methods that come into play. Expanding agents, like one brand called betonamite, are a really fascinating alternative. They're basically just these powders that you mix with water and pour into holes that you've already drilled. It's completely non-explosive, which means no bang, and you don't even need a special license to use it. The power here comes from a quiet but totally unstoppable chemical reaction. As that slurry mix hardens, it expands with a force of up to 8,000 tons per square meter. That's more than enough pressure to silently crack solid rock and concrete from the inside out without making a single sound. And that right there is its huge advantage. As the source material puts it, it's a gentle and environmentally friendly alternative. It's absolutely perfect for working near sensitive buildings, hospitals, or historic sites, anywhere you need to break stuff apart without any noise or shaking. And if we look to the future, there are even more high-tech methods being developed.
Something called electrodynamic fragmentation, or EDF, uses these powerful, ultra-short electrical pulses underwater. These pulses zap through the concrete, shattering it along its internal boundaries and basically breaking it back down into its original components of stone and cement. Really cool stuff.
Okay, so tearing a building down is one challenge, but what's inside it can be a much bigger and way more dangerous problem. We have to talk about the invisible hazards that demolition crews have to deal with.
One of the biggest concerns in older concrete structures is asbestos. For decades, these small asbestos-laced spacers were used to position the steel rebar inside the concrete forms before they poured. Now, when that bridge or building gets demolished, those tiny fibers can become a massive health hazard if they're not handled perfectly.
So, before any big demolition can even start, there's this meticulous three-step process. First, they do a thorough investigation to map out exactly where all the hazardous material is. Second, they have to carefully remove it. And this isn't brute force, it's precision work, using techniques like milling away contaminated surfaces or using high-pressure water jets to blast it out. And finally, all that waste has to be disposed of according to super strict safety rules.
And this is where that new tech we talked about circles back. Techniques like electrodynamic fragmentation are being tested specifically for this problem. The hope is that EDF could cleanly separate those asbestos spacers from the concrete rubble after the demolition, which would make the whole cleanup process way safer and more efficient.
So the structure is down, the hazardous materials are gone, but we are not done. In this last section, we're going to see how demolition is really just the beginning of a whole new process called urban mining.
The modern demolition site is basically a recycling plant now. This concept of urban mining treats all that rubble not as waste, but as a valuable resource. Huge mobile processing machines move right onto the site to crush, sort, and refine all the debris on the spot. And this whole process is incredibly sophisticated. You have powerful crushers that turn concrete into reusable aggregate. Giant magnets pull all the steel out for recycling. Big sifters separate everything into different sizes for different uses. And they even have wind sifters that use jets of air to blow away the lighter stuff like wood and plastic.
So clearly, demolition has transformed from just brute force into this highly tuned science of deconstruction and really rebirth. It forces us to look at our cities not just as places to live, but as material banks for the future. And that leaves us with a final thought. If today's rubble is tomorrow's resource, what are we going to choose to build with